Okay, in a previous video in this tutorial series, we have already selected the color order for these two different pixels. So I'll just quickly remind you, on this DMXpix, we have an LPD 8806 pixel strip on the B output, and we have an APA 102 pixel strip on the A. That is an Adafruit dot star pixel string. And I want to point out too, normally in this application, of course, the pixels are individually addressed, and that's what pixel tape is about. But for doing color match, which is what we're showing here, it helps to just have many pixels react exactly together. So then we get a wider view of an overall white, and that's how we do this. We do a white balance. So let's first look at our screen and see that we have, as I said, selected the APA 102 string, the dot star, in driver A. In the previous tutorial, we discovered that the color order is blue, green, red, and by selecting that, we will control from our console and get red, green, blue. That's the color order adjustment. And for color match, these are values that represent ratios to adjust errors in the way the levels of the colors render a white. And likewise over here in pixel driver B, this is the LPD 8806 string. Its color order was green, red, blue. So when we've selected that option, we've corrected it so it will operate as red, green, blue. And once again, the color match values are at the maximum to give us exactly what the hardware is going to look like. So now we can switch over to Virtual TX, put all the channels on, and we can see right away that the dot star is quite purple. And the LPD 8806 is kind of a bluey green. Certainly neither of these is the kind of white that we'd be happy with on a set, whether motion picture or theater, especially if it's up beside other fixtures that are true white. So the point here is to find an offset that is much more pleasing. So let's start with the APA, and we're looking at half, so we can actually see the adjustment. So if I bring this down to, I think around there, that is much more neutral, and you can see the original over here is very purple, and I've neutralized that out over here. And let's look now down on this one, see if we can do something similar there. And we can. So now we are likewise trying to neutralize those things. And that is looking, that's looking quite good. Let's play. That looks pretty good to me. So you can see this section now, we've done the color adjustment, and over here we're still seeing the original colors for comparison. And we've ended up more neutral over here, and we have the values here on the screen, this for the APA, and this for the LPD, and we can use those now and go back over here. Let's turn that off. Come back over here and we'll type in those corrections. So on this one we had 146 in the blue, and on this one we had 172 and 166. These are our offsets. And we send those to the device. Come back over here, throw it all on full, and there, notice now I've done all of it, so we don't have the before and after, and we can't because we've corrected it. The new values are in the pix, and this hardware group of these two particular strings and this particular pix now have stored everything they need to know to always respond to red, green, blue channels. When they go to full, we get the correct white. And if you do this with all of the pixel strings throughout your show, they can all be different brands, different pixel resolutions, manufactured at different times, different chip types. And by making all the whites balance, now it doesn't look like a haphazard array of different products. You can just grab stuff out of the drawer and make them all look great. That's what RC4 Color Match is about.